All right, let's go over the Chapter 2 test. Determine if f of x is a function. A function has it so that no domain element goes to different range elements. So we have 8 going to 3, 4 going to 2, 5 going to 2. It doesn't matter if the range repeats itself. It's the domain has to not go to two different elements. So I have a domain of 8, 4, 5, 6, and 7. And they're going to, let's see, the 8 goes to a 3. We have the 4 going to a 2. We have 5 going to a 2. That's not a problem. We have 6 going to the 2. That's still not the problem. 7 going to a -1. That's okay. But we have 8 up here now going also to 2. And there's the problem. 8 is mapped to, or is paired with, or has an output of 3 and 2. So not a function. Is the following curve a function? And these are all 1 unit squares, and a function has to be for every x only one y. Well, if you go above this x, you get only this y where you hit the curve. This x down here, this x over here. Now, several people said that there's not two y's or whatever. They said some really strange things. For every x, there can only be one y. And in this case, that is true. So it's a function. Now the test for that is a vertical line test. A vertical line drawn anywhere on this graph hits the curve only once. Any one vertical line will only hit the graph once, and so it is a function. It says, what's the domain for the first one? Well, the domain is 8, 4, 5, 6, and 7. So we can write that. We should list that as a set. The set whose elements are 4, 5, 6, 7, and 8. That's a good way to do a list. B, 5x minus 3 is under a square root, so it cannot be negative. It can be positive, greater than 0, or equal to 0. To solve this, we'd add 3 to both sides, and we get 5x greater than or equal to 3. And then we'd have to divide by 5. Now, dividing doesn't flip the sign. It's dividing by a negative or multiplying by a negative. 5 in this case is positive. So we get x is greater than or equal to 3/5. We'll make this inside positive. Now we can either write it in set notation or say x is greater than 3/5. That would be from 3/5 on to infinity. That's where it'd be greater. And this says equal to 3/5, so we could include it and not the infinity. So that would be interval notation or set notation. Or you could say all reals greater than or equal to 3/5. You could write it out in words. C. This is a ratio. There is a denominator to this fraction of expressions. You cannot divide by 0. We don't care if the numerator is 0. The denominator can't be 0. So x squared minus 4 cannot equal 0. So if you add 4 to both sides, x squared cannot equal 4. Well, x squared would equal 4 when x was 2, so it can't be that. And negative 2 squared would equal 4, so x cannot equal negative 2. So we could say it's all the numbers such that the numbers are not 2 or negative 2. And I should say there. So that would look like an interval notation that we could use from negative infinity all the way up to negative 2, but not including it. Union, we could go from 2 to negative 2 to 2. Union, and then we can go from 2 to infinity. Everything except negative 2, we skip over it, and positive 2. That's page 1. Page 2. Find the domain. That's what x's we have values for. Looks like it starts at negative 10 with a solid dot, so negative 10, and it works its way up to, oops, there's a hole. So we got to leave that out. That's at 1/2. So up to 0.5, can't include it. Union, we can go on though from 0.5 on up to 2, and it looks like there's another hole, so we can't include the 2. Union, but above 2 up till 9. Notice I'm only looking at the x's. Domain is what the x values can be. Find the intercepts. Looks like it crosses right there. That's at negative 8.4 approximately, comma 0. Intercepts are points, so they should be reported as points. It also crosses at negative 1.8 roughly. Negative 1.8 on the x-axis, 0. And it has a y-intercept, looks like about 5.9. That's 0, 5.9. These are points, so they should be in parentheses, not brackets or anything else. Evaluate the y value at 3, m of 3. At 3, the y value is about 2.5. Don't give me the point, 3, 2.5. Give me the y value, that's what it says. Give me the y value at negative 6. At negative 6, the y value is negative 8. Local maximums. That's where a high spot, where everything in the near it is lower. That looks like it would be there, but it's no spot at the top. Can't be here because we don't know whether it's higher or lower on this side, and same over here, so there are no local maximums. Local minimums. That's where you stand on the curve and everything looks like it goes up around you, which happens here. And the local minimum is, how high is it? Negative 9. You can say at x equal negative 5, but it's negative 9 is how low it is there. And it also has a low spot here. Both these places would catch water, and that's at 1.8 approximately. So at 9, negative 9 is a low spot, a minimum, and also at 1.8. Absolute maximum. That's a very highest spot on the graph. That's defined. So something like this, you couldn't use it if it's open circle, but that's higher, so we wouldn't even need to look at that. And this is even higher, and that is 10. It gets clear up to 10. And it says, what's the absolute minimum? Well, how low does this graph get to? Well, it gets clear down to negative 9. And for what interval is the function increasing? So when we ask for these intervals, we're talking about for what x values is the y going up? Well, it starts at x at -5, not including, but around -5 it starts going up, and it stops going up around 0.5. And then there's another place that it goes up, and that's from around 4 on the x to 9 on the x. So it increases for x's between -5 and 0.5. Between -5 and 0.5, the graph is increasing. And from 4 to 9, the graph is increasing. Y equals 2 plus x. So if I just drew a graph and made each square worth 1, and then put in 0, I would get 2. Put in 1, I would get 3. -1, I'd get 1. Into this y equals 2x plus 2 plus x. So I have a line that's going like this. But I'm only supposed to draw it for x's less than 1. There's x equal to 1, so this part of the line. Up to it, but not including. Y equals 3x. 3 times 0 is 0. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. So I got a line that's going like this. But I only draw it for the numbers between 1 and 3. So that would start here, and since it can be equal to 1, we actually fill that circle in, and we go up to 3 and we fill that one in it. No open circles. It says give the intercepts. Well, we can't use that one because it's not on the graph. This is the graph, but it crosses the x-axis at -2, 0. Intercepts are points. Crosses the y-axis at 0, 2 on the y-axis. What do you get at -1? 1. Or -1 is less than 1, so we'd use this. 2 plus -1 is 1. What do you get for 1? Well, on the graph, 1 is 3. 1, we'd use the bottom one here, because 1 is between 1 and 3, and this including the endpoints. So we put 1 in there. 3 times 1 is 3. What would we get at 4? Well, this graph stopped at 3. It didn't get out to 4. 4 is not in between 1 and 3 or equal to the ends. It's not less than 1, so this is undefined. The graph doesn't show it, and the domains up here don't show it. So that's it. And finally, oh, I guess not finally, we got 2 more pages here. So f minus g. F is x squared minus 3x. Subtract, so I better put some parentheses on here, g, which is 2x plus 3. So this negative here gets distributed, so I have x squared minus 3x minus 2x minus 3, and these are like terms, so I get x squared minus 5x minus 3. F times g, so I have x squared minus 3x taken times 2x plus 3. So x squared times 2x is 2x to the third. X squared times 3 is, and that's plus, 3x squared. Negative 3x times 2x is negative 6. X times x is x squared. And negative 3x times a positive 3 is negative 9x. These are like terms, so I get 2x to the third minus 3x squared minus 9x. It says use f, the x squared minus 3x. Put x plus h in place of the x's. So I have x squared, so I get x plus h squared, because I'm putting x plus h in place of the x's. Then I have minus 3x, but in place of the x, I'm putting x plus h. And that's what f of x plus h is. Minus. So I got to distribute the minus to f of x, which was x squared minus 3x over h. And we're supposed to simplify this. Well, x plus h times x plus h squared is x squared plus xh plus xh plus h squared. X squared plus xh plus another xh, that's two xh's, plus h squared. Then this minus 3 times this quantity is minus 3x minus 3h. And this minus times into those two quantities is minus x squared plus 3x over h. The x squareds cancel. The negative 3x and the plus 3x cancel. So we have 2xh plus h squared minus 3h divided by h. You can factor out an h and get h times 2x plus h times h is h squared minus 3 times h is minus 3h over h. And now these h's cancel and we get 2x plus h minus 3. D. G is 2x plus 3. That's on top. But we're supposed to use 2 for the x. So it's 2 times 2 plus 3 over f. And f is x squared, but we're supposed to use 2 for the x. So 2 squared minus 3 times x, which is 2. 4 plus 3 is 7. 4 minus 6 is negative 2. Okay, now we got to do the transformations. The parent function here is y equals x squared. So 0 squared is 0, 1 squared is 1, 2 squared is 4. And I better put units on my graph. 1 here and 4 up there. And I'll go to the next one. And in class we said we'd do the inside ones first. So the only thing inside the square is the minus 1 on the x. Inside works horizontally, minus 1. Anything inside works opposite, so this would go, instead of negative 1, it would move it to plus 1. All the points moved over 1. So I'm going to write each one of those points 1 to the right. So that's 1 and this is 4. So I got units on my graph. And I've described the step. Now I have to deal with the numbers on the outside. And on the outside there's a 2 and a 3. On the outside you do in order like it sounds like it should be. So according to order of operations, you multiply before you add. So 2, this is on the outside, so it's working vertically. 2 times it would make it go twice as far from the x-axis. Well, that's on the x-axis, so it stays. This one's up 1, so it becomes up 2. On the y-axis there, it was up 1, so now it's up 2, twice as far from the x-axis. So this is becoming a vertical stretch by a factor of 2. And the point that was at 2 over and up 4 would become 2 over and up 4, 8. Now you might think it looks like a compression, but it's not. It's a vertical stretch. This is 1, and I'll mark the 4 again. And finally, the 3. The 3 would take and move this whole graph down, up 3, because it does it just like it says. So this one is going to go up 3 because it's a positive 3. So this point goes up 3. The one that was over 1 was up 2. Not 1 anymore because of the vertical stretch. And so this was 1 and this is 4, and there's where the graph would be. 8 points. Now we got to do the absolute value. And of course the absolute value curve is a V. Absolute value is 0, 0. Absolute value 1 is 1. 2 is 2. Negative 1 is 1. Negative 2 is 2. Negative 3 is 3. It's just the V. If that's 2 and that's 2. That's the parent. Now, everything is inside the absolute value on this. So everything works horizontally. Everything works opposite of what you think and backwards. So we have a minus 2 times the x and then plus 1. Plus 1 would normally be the last thing, so we're going to make that the first thing. A plus 1 on the x moves it minus 1, opposite what you think. So that's going to move it minus 1. So that's a shift left 1. Then we have to deal with this minus 2. And you can do the 2 first or the minus first, doesn't matter. I'll do the minus first because it comes before that. So minus horizontally times the x flips it over the y-axis. So this 1 at minus 1 becomes 1 on the plus side, and the V looks like that. And so we reflect it over a y-axis, horizontally over the y-axis. And now we got to do the 2. This is working horizontally, so it's not a vertical stretch, it's a horizontal because it's inside. And we would think that times 2 would make it twice as wide. but everything's opposite inside, so it's half as wide. So it's a compression by a factor of 2. The compression is always to the axis. So this was over 1, it gets pushed half as far from the axis. If it's 1 away, it goes to half away. This one up here above the 2 is at 1, so it goes half as far away, which would put it at 1. The one at 0 is on the y-axis, so it doesn't move. The one at -1 goes to -1/2. The one at 3, which is 3 away, goes to 1.5 away. And it should look like this graph the graph has been squeezed together. Y equals x to the third minus 2x. You can, to check these, some evidence you can do is just, you could try graphing it and talk about whether it's symmetric, but you can also just test a point. Like you can put in 2, cube it, minus 2 times 2 we're putting in for the x, and we get 8 minus 4, which is 4. So we have put in a 2 and we get 4. Now let's put in -2. So where there was x's, we put a -2. -2 times -2 is +4 times -2 is -8, and subtract 2 times -2 is that's -4, so subtract the -4, that's +4. So we get -8 plus 4, which is -4. So we get 2 we put in a -2 and we got 4, -4. So changing the sign of the x changes the sign of the y, and that's called an odd function. Changes the sign but the same number. Next one, y equals 2 times the absolute value of x minus 1. So if you put in 2 for the x's, 2 minus 1 is 1. Absolute value of 1 is 1 times 2 is 2. So if you put 2 in, you get 2 out. Now let's put in -2. So we have 2, absolute value of -2 minus 1. So inside there we're going to have to go -2 minus 1, which is -3. Absolute value of -3 is +3 times 2 is 6. We put in -2, we get 6. They're not the same, and they're not the same but opposite in sign, so this is a neither. This one, x squared minus 2. If we put in 2, we get 2 squared minus 2. 4 minus 2 is 2. So we put in 2 and got 2. Now we'll put in -2. -2 times -2 is +4, minus 2 is 2. So we put in -2 and also got 2. Got the same number out for the plus and minus, and so this one is even. That's what an even looks like. And finally, we got this graph. We got a rectangle under this graph. The graph has the equation. The y value, or f of x, is 6 minus 0.3x squared. And they want the area of the rectangle, and that's length or width times length, whatever way you want to go. That would be the x out to here, because p is at xy. So it would be x times y, but y is 6 minus 0.3x squared, and that's 2 points. And then if you put it into your calculator and graph this, it makes a graph that looks like comes up and goes down and goes up, and the x that makes it maximum is what you're supposed to find. So you use second calculate, find the maximum, and it'll give you 2.57 or 8, something like that, is the x value that gives you the maximum. And the maximum height is about 10 point, the maximum area is 10 point something. Height on here, but it's actually what's the maximum area for the rectangle.